Good morning, everyone. Again, I'm sorry that I'm not here today. Yesterday, I was gone interviewing and doing the same today. I will be back tomorrow, and tomorrow we're going to go over any questions that you have over this homework, the homework that you were supposed to do last night that we're actually going to go over right now. But still, I know it's different when I'm here in person. So if you're still struggling with it, tomorrow we'll go over it as well as the homework that you're going to get tonight. So I want to go ahead and jump in to these problems since there are several of them. And again, because I'm only going to make about a 30-minute video, I'm going to go ahead and go pretty fast. And then if you have any questions, then we can revisit these tomorrow. Okay? So a random two-digit number is drawn from the numbers 10 through 99, and they want to find the probability that you're going to get an odd number. Well, if you think about it, if you calculate how many that is from 10 to 99, 99 minus 10 is 89, but you got to include 10 as well. So there are 90 total. So 90 obviously has got to be my bottom number. And then if you think about how numbers work, you have odd, even, odd, even, odd, even. So you're going to have exactly the same amount of both. So you're going to have 45 out of 90 that are going to be odd. Now, obviously, that is going to reduce. So that's why it should make sense that our odds of pulling out a odd number would be 1/2, 1 out of 2. Okay? Pretty easy one. For number 4 and for number 6, we're using the word candlestick, which is 11 total, okay? So right off the bat, we know that our bottom number has to be 11. That's our total. So out of those, they want to know what's the odds that it's a vowel. Well, we talked about vowels a little bit yesterday. You've got A, you've got E, and you've got I. So you have 3. You have 3 vowels here, so this is going to be 3 out of 11. Now, I would always encourage you guys to use your alpha y equals key in your calculator to see if these will reduce. 3 over 11 will not, so we're going to leave it be, okay? And then, of course, number 6, you can kind of use what we talked about yesterday as being the complement of an event, where if you wanted to, you could either tally up how many are not C's. Our bottom number is still going to be 11 because there's still 11 letters. So you have one of two options. You can either tally up all the ones that are not C's, or you could say, well, there are 2 C's, so it's 1 minus 2 over 11. Again, I'm not going to be real picky in a situation like this, whether you use the complement of the event or if you just go ahead and find the probability of that yourself. It's going to do the same thing. You're going to come up with 9 over 11, which again will not reduce. So there it is, okay? 9 over 11. I told you all the evens, so we're just going to kind of scroll through here. Number 8, a month is randomly chosen. What's the probability that the month chosen has less than 31 days? So again, how many months are in a year? That's 12. So our bottom number is going to be 12. Now, I don't know if you've ever seen the knuckle trick. The knuckle trick, pretty good. It's like you got your knuckles. All right, there's your left hand. Then your right hand jumps back up. All right, so these are your knuckles. Okay, if you set them next to each other, you got January, February, March, April, May, June, July, August, September, that's an S. September, October, November, December. And all the ones that are at the top have 31 days. Okay, all of these have 31 days. So how many have less than 31? Well, that would be February, April, June, September, and November. That's 1, 2, 3, 4, 5. So you have 5 out of 12, which actually will not reduce. So we'll leave it there. You could have also done the complement. There were 7 that did have 31. So 1 minus 7 over 12 would be 5 over 12. Okay, if I were to have done it that way, it works just the same. Okay, you're going to get the same value. If y'all have never seen that knuckle trick before, it's pretty good. It helps you to remember the ones that have 31 days are all the knuckles, and then the ones that are below are the ones that are below. Most of them, of course, are 30, except for February, of course. All right, number 10. Credit cards place a 3-digit security code on the back of cards. What is the probability that a code starts with the number 7? All right, so this one's a little bit more challenging. So let's start with the bottom number. Okay, what's the probability, or what's the total possibilities that you could have 3 digits? This goes back to our fundamental counting principle that we talked about the week before we were gone for fall break, or I'm sorry, spring break. To come up with how many different codes you have possible, remember, every one of those digits could be a 0 through a 9. 10 different possibilities. So you have 10 times 10 times 10, because there's 3 digits, and all of them could be that many possibilities. So that is going to be your bottom number. Okay, now I'll go ahead and do the math on that. You're going to have 1,000. Okay, 1,000 different 3-digit codes. All right, very simple. Now, how do I do the top though? Well, remember, it's asking what's the probability that a code starts with the number 7. So that means how many different possibilities could have been that first value if it was supposed to start with a 7? Well, there's only one 7. Now, did it say anything about what the next 2 codes could be? Absolutely not. They could be anything. They just can't be 7. So what you do here is you multiply 1 by 10 times 10. So that is 100. Now, 100 over 1,000 will definitely reduce, and that reduces down to 1 out of 10. All right, that's the possibility. All right, number 12. Michaela has the following songs on her iPod: 14 Taylor Swift songs, 16 Meghan Trainor songs, 17 Katy Perry. And I know these are outdated probably on what you guys are actually listening to, but whatever. What is the probability that the next song plays not Katy Perry? Okay, so look, if 17 are Katy Perry, we have 2 options. You could do the complement, or you could tally up the ones that are not Katy Perry. I like to do complements when I see that word not. So I say, hey, how many are Katy Perry? Well, that's 17 out of a total, and you just add them up. 14 plus 16 is 30, plus 17 is 47. So it's 17 out of 47 are Katy Perry songs. So what's the probability that it's not Katy Perry? Well, it's 1 minus 17 over 47. It's the complement, which is 30 over 47. And since 47 is a prime number, it will not reduce. So there it is, 30 over 47. All right, number 14. A coin is tossed, then a number 1 through 10 is chosen at random. What's the probability of getting heads, then a number less than 4? All right, so first of all, you have a single probability, right? We are dealing with one thing. Here we have multiple possibilities. So what did I say when you have multiple events? You multiply your events. So I'm going to go ahead and say, hey, I got 2 events going on here. So I'm multiplying these 2 events. So first, what's the probability of getting heads? Well, that's easy, right? We've talked about that a lot. There are only heads and tails, so there's 2 sides. There's only one side that's heads, so 1 out of 2. But then, what's the probability of getting a number less than 4? Well, remember, 1 through 10, it eliminates 0, obviously. 0's out. But it includes 10. So that's 10 possibilities, 1 through 10. But less than 4. Now, remember, less than 4 means you don't count 4. It's got to be less than 4. What numbers are less than 4? Well, that's 1, 2, and 3. So there's only 3 of those. 3 out of 10. So we're going to multiply the events. 1 over 2 times 3 over 10 equals 3 over 20. And if you did that with your graphing calculator, it won't reduce. So what you get there is going to be your answer. Okay? Hopefully you guys will flip it over to the back, number 16. A card is drawn from a standard deck, and a letter and two events, multiple events, multiply events. A letter is chosen from the word incredible. What's the probability of drawing a king and getting an eye? So, multiple events, we multiply events. I know that's annoying, but it helps you to remember it. So first and foremost, kings. We talked a little bit about cards yesterday. To get a king, there are only one king in each suit, and there are 4 suits. So that's 4 out of a total of 52 cards, which we discussed yesterday. So what's the probability of drawing a king? 4 out of 52. Then getting an eye from the word incredible. Now again, that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. And how many are eyes? You got 1, 2. You got 2. 2 out of 10. So that's 4 over 52 times 2 over 10. If you type that in your calculator using your alpha y equal key, it'll simplify them for you, and it simplifies this one down to 1 over 65. Done. Let's keep on cruising along on number 18 and 20. We're looking right here at this bag that contains 30 lottery balls numbered 1 through 30. A ball is selected, and then look, here's the key word we talked about yesterday. It's replaced. It goes back in the bag. So does it affect the next draw? Not at all. Then we draw another one. So multiple events, we're going to multiply events. So I'm going to go ahead and set that up. Multiple events, we're going to multiply events. So let's see what those events are. 1, what's the probability of drawing a 7? Okay, well, how many 7s are in the numbers 1 through 30? Just 1. Only 1 7 out of all 30 of these balls. So you got a 1 out of 30 chance right off the bat. And then a number greater than 16. Now, time out. We still have the same bottom number, right? Because that 7 went back in the bag. So you still have all the numbers 1 through 30 in there. So you have 30 balls back in the bag. How many are greater than 16? Remember, greater than 16 means we don't count 16. So we count 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. We include 14 numbers, if you were counting with me. So it's 1 over 30 times 14 over 30. And that, if you type in your calculator, will reduce to 7 over 450. Next, again, the probability of 2 even numbers. If we have multiple events, you multiply events. Now here's the beauty of this one. You're replacing it. So what's the probability of drawing an even number? Well, remember, it'll be half of them. You could say it's 15 out of 30. You could say 1 over 2. I don't care. It's half of them. But it's half of them both times. Okay? Because you replace it. It doesn't affect the next draw. So it's 15 over 30 times 15 over 30, or 1/2 times 1/2, which equals 1/4. Now, all of a sudden we change. And in the next one, it says that you've got this bag, and the ball is selected, and then it's not replaced. See, that's a much different type of problem. That means whatever you do the first time, it does not go back into the bag. And because it doesn't go back into the bag, it's going to affect sometimes the top number, but all the time it'll affect the bottom number. Okay, look at number 22. We got multiple events still. We're multiplying events. So let's first start with the probability of drawing a 19. Again, like the one above, 7, you only have 119 out of the 30 balls. Okay, the 30 lottery balls. And then a multiple of 4. Now think about this though, guys. I no longer have 30 balls in the bag because you drew one out. And if it just so happened to be a 19, great. That gives us a chance for the next one. But I only have 29 balls in the bag. So what I got to think about now is, well, what are my multiples of 4? Well, I've got 4, 8, 12, 16, 20, 24, and 28. Those are my multiples of 4. So I don't know if you're counting with me. That's 7. So we had 1 out of 30 chance of picking out of 19. And then if you were so lucky, how many are left? Only 29 balls. How many are multiples of 4? 7. So it's 1 over 30 times 7 over 29. So multiply that out using your calculator. You got a 7 out of 870 chance. Crazy. Crazy odds right there. And then finally, the probability of 2 perfect squares. Again, right off the bat, we got 2 events, multiple events, multiply events. Let's start with 1 perfect square. Well, again, same bottom number, right? 30. But how many of those are perfect squares? Remember, perfect squares are when you multiply something by itself, you get that value. So like, for example, if I start with 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. All of a sudden, we're above 1 through 30. So these are my only possibilities. There's 1, 2, 3, 4, 5 of them. Now, here's where not only does it affect my bottom number. See, you're not replacing it. You happen to have picked out one of these. Let's say you picked out the 9. It's gone. You had a 1 out of, you had a 5 out of 30. I was going to say 1 out of 5 or 1 out of 6. You had a 5 out of 30 chance of picking that out. It's pretty small odds, but it's gone now. So not only does it affect the bottom number, I only have 29 balls left in that bag. But if I just so happen to have picked out a perfect square, now I only have 4 perfect squares remaining. So 5 over 30 times 4 over 29 is 2 out of 87. Those are the odds. And that leads us to the last one, number 26. Ryan's mom randomly chooses 2 days each week for Ryan to do his chores. What's the probability that she picks Saturday and Sunday? All right, so again, she's picking 2 days. Multiple events, you multiply events. Well, first and foremost, how many chances did she have to pick a Saturday and Sunday first try? Well, that's 2 days out of 7. But she's choosing 2 days. So if she happened to have picked Saturday, Saturday's gone. You only have 6 days left. And how many of them are Saturday or Sunday? 1. Only 1. How come? Well, you already picked the other one. It's gone. So this is the not replaced. This is the idea of dependent. Okay, it's depending on the previous pick as we make decisions about the next one. So it's 2 over 7 times 1 over 6, which is 1 out of 21. You have a 1 out of 21 chance. All right? So there it is. Listen, if you struggled understanding this still, hold on to this until tomorrow, and we will discuss it. Now, while this was happening, the substitute has passed out this paper right here, conditional probability. So get that out, and we're going to go through this together. So, given events A and B, this is called conditional probability. Conditional probability is the probability of event B occurring, knowing that event A has already occurred. All right? That's what conditional probability is going to be about. So you would note this as the probability of B given that A already happened. Okay, read as the probability of B given A. Now, I'm going to show you this. This is what it looks like from if you were to say a formula standpoint. You got the probability of A and B happening on top, and on the bottom you've got the probability of A. This is how you would do it, but we're going to think it through a little differently, okay? So Let me explain. Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? Now, according to what we just went over, if I were to do this whole formula, it's going to look differently than what I want you guys to consider. I want you to remember that the given that is your bottom number, okay? The given that is your bottom number. So here's the point. How many cards in the standard deck are red? Well, it's half your deck, right? It's 26. 26 cards are red. Out of those 26 cards, how many are queens? You might think about that. Remember, there's 4 queens, but 2 of them are black, right? We have the spades and clubs. Given that they're a red card, how many queens do we actually have? We only have 2. So we have 2 out of 26, which reduces to a 1 out of 13 chance. Okay? Hopefully that kind of makes sense. I think it will, especially as we do a few more. Okay, look at the next one. It says a number from 1 to 100 is randomly selected. What is the probability that it is a perfect square given that it's an odd number? So here's the point. We're only focused right now on those that are odd numbers, right? Now, I could write them all down, but you know if this is 100 numbers, how many are odd? Well, obviously, it's going to be half of them, so 50. So we're only talking about our odd numbers. So out of the group, only odd, it wants to know how many are perfect squares. Now, if I do all my perfect squares from 1 to 100, it's very simple. It's 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. There they are. However, am I counting all those? No. It says, given that it is an odd number. So that eliminates immediately, I don't even count the ones that are even because they're not a part of my given that. So I'm only talking about 1, 9, 25, 49, and 81. I'm only talking about 5 of these 50 numbers. So 5 over 50 reduces to 1 over 10. So the given that is going to actually simplify your bottom number. It's going to make it much smaller, and then you base your decision on the rest. Number 3. These are a little different. So we're going to look at them a little differently. It says there are 62 people that take a yoga class and 48 people that take a spinning class. 15 that take yoga also take spinning. If a person from these groups is selected at random, find the probability that he or she is taking, it's misspelled there, is taking yoga class. If you know they take spinning class. Okay, now this looks all confusing. So let me show you what we can do to kind of help us out. We are doing, look at what it says, the probability that they're taking yoga class given that they are in a spinning class. Okay? So here's the point. If I were to look at this as 2 circles that overlap, what are those 2 circles? Well, we got people who take yoga, right? How many take yoga? 62 total. Then we got people who take spinning class. How many people take spinning class? 48. But there are how many people that do both yoga and spinning class? Well, there's 15. So there's 15 people, and I probably should have made these a little bigger. Let me just zoom in. There are 15 people who are overlapping that are in both categories. So here's the point. If we're talking about yoga, how many people only do yoga? Well, if 15 people do both, out of the 62 people that did yoga, 62 minus 15 is 47. Only 47 only do yoga. Does that make sense? I hope it does. We do the same thing with spinning class. In the spinning class, 48 people take spinning class, but 15 of those do both. So 48 minus 15 is 33. 33 people do only spinning class. All right, so let's answer the question. It says, what's the probability that they do yoga given that they do spin class? So here's the point. We are limiting it only to those that are doing spin class. We are limiting it to only 48 people. Now, out of those 48 people, how many people do yoga? 15. 15 out of 48. And that will reduce to 5/16. Okay? I know that's a little harder, but hopefully that will make sense. Let's do another one of those. And then I'm going to have to stop this video because I only have 30 minutes that I'm allowed to record. And then I'm going to do a secondary video, and you're just going to switch from one to the next. Sorry, I wish I could do more than 30 minutes, but my Screencastify is messed up, and I had to do this separately. Anyhow, it says, of the 30 students in Miss Smith's math class, 13 are athletes and 9 are in the band. 3 of the athletes are also in band. If one student is chosen at random, find the probability that the student is in band if it is known that they are not an athlete. So here's what we're doing. We're doing the probability that they're a band member given that they're not an athlete. Okay? Now, we're going to do the same thing. We're going to do 2 circles because we're actually comparing 2 things, right? We're comparing those that are athletes and band. Okay? So let's understand. There's a total of how many people in this class? 30. Okay? 30. How many are athletes? 13. And 9 are in the band. 3 of these are, it says 3 of the athletes are also in the band. So how many do we have in this overlap? We have 3. 3 are in both. Now, if 13 are athletes and 3 of them are in both, how many are athletes only? 10. And if we have 9 people who are in the band, but 3 of those are athletes also, how many are only in the band? Well, that's 6. Okay, that's 6. So here's the question that's asked. We're trying to find the probability that they're in the band, given that they're not athletes. Okay? Now listen, the tricky thing with this is, like the last problem, we only focused on the circles. But this time, remember, how many students were actually in Miss Smith's class? 30. Okay? 30. Now, think about this. How many are in the band? There are 9, right? There are 13 who were athletes out of the 30 who are in this class. So how many are not athletes? Well, if it's 30 students in the class and there are 13 who are athletes, there are 17 people who are not athletes. Now, out of that, what I've highlighted in red, how many are just band? Only 6. Only 6. Because those 3 right there in the middle, they don't count. It's only these 6. Because the other 3 are actually athletes. So that's 6 out of 17, which will not reduce. All right, you're going to stop this video and begin the next one.